Hello, so here we will see different kinds of matrices, okay, and basically the important kinds of matrices which we have encountered, and actually it can appear anywhere actually. So what are different kind of matrices? So matrices means is kind of an arrangement of numbers, right? So some numbers and there is an rectangular arrangement, okay. So you know that these are rows, right? These are rows, okay. So what is the number of rows? You write it first. Let's say m is the number of rows, and similarly here in this direction they are what? They are columns, okay. How many are there? If there are n, you just write n. So then the order of the matrix is m cross n. For example, if I give this matrix, okay, 2 3 1 4 5 2 0 2 3 1 0 3, okay. So how many rows are there? 3 rows, right? So basically 3 cross first rows, okay, first rows, and then columns. How many columns are there? 1 column, 2 column, 3 columns, 4 columns. So 3 into 4. So the matrix order is 3 cross 4. Now if it is square, for example, 2 minus 1 3 0. How many rows are there? 2, okay. And how many columns are there? Columns are also 2, right? So order is 2 cross 2, right? If order is 2 cross 2, it is, so order is n cross n, it's called a square matrix, okay. So order is 2 cross 2 means it's a square matrix. You can just say it is a square matrix of order 2, just 2 you can say. So basically if you are saying only one digit as your order, then it is, so basically if you are saying one digit, it is actually n cross n. If you are saying order 2, it is actually 2 cross 2, or you have to specify both the number of rows and columns, okay. So fine. First question is a matrix of order 4 cross 3. So basically given example, what will be a matrix of order 4 cross 3? It is clear that there must be 4 rows and 3 columns. You can write any 4 rows actually and 3 columns. So suppose you take 1 3 1. You can actually also repeat the entries like 1 1 1 2 2 2 and 3 4 1, whatever you write, okay. You have to just make 4 rows, okay. Basically this is the number of rows, right? First one, and this is the number of columns, okay. First one is rows, second one is column. So check 4 rows. Yes, 4 rows are there, and 3 columns. Yes, 3 columns you can see. So this is a matrix of order 4 cross 3. Now a row matrix means what? There is a single row, which means what? There is a single row means only one row. So number of row is 1. Number of columns can be anything actually, okay. So suppose that there will be only one row. Remember 1 2 minus 1 0 3 4. This is a row matrix or not? Yes, because there is a single row. You can see only a single row, which means this is a row matrix. But this is also a row matrix. Just write 1 or 2. This is also a row matrix, okay. Because why? There is only one row. Only one row means a single row. That is a row matrix. Similarly, what will be column matrix then? You will see a single column, only single column. You can write any number of entries here, 1 3 minus 5 2 10, but you see only one column, which means this is a column matrix. So a column matrix means only one column, But if I ask what is the order of this matrix, only one column, which means the second entry is 1, because the second entry represents the number of columns. But how many rows are there? Yes, you have to again start counting 1 2 3 4 5. So this is a 5 cross 1 column matrix. Similarly, if you just write only 3 elements, then it is a 3 cross 1 column matrix. This is also a column matrix because you see only one column, okay. Next is what? A zero matrix of order 3. So zero matrix means all entries in the matrix, all entries are only zeros, right? So zero matrix of order 3 cross 3 means row 3, column 3, you just put zeros there. So row 3, column 3 means it's a square size matrix, and zero matrix means all are zero entries, okay? So a diagonal matrix means, what is the diagonal? Suppose a matrix is written, okay? A diagonal matrix means it is always a square matrix, always square, okay? Always square matrix. Now suppose you write a 3 cross 3 matrix, 1 2 3 1 2 3 1 2 3, okay? If this is the matrix, then what is the diagonal? This is the diagonal, okay? This is the diagonal. And a diagonal matrix means only, so this means only diagonals, only diagonal entries, only diagonal entries are possibly only diagonal entries are possibly non-zeros. Which means what? Which means, in other words, actually, outside the diagonal, similarly, actually, outside the diagonal, which means what? Outside this, okay? Outside the diagonal, all entries must be zero, which means what? So for example, if I write this, let's say 2 0 1 0 minus 1 0 0 0 5, okay? So what is the diagonal? The diagonal is clearly this. This is the diagonal. Now outside the diagonal everything is zero. Yes, outside the diagonal everything is zero, therefore this is a diagonal matrix. But if I write this way, for example, 3 0 1 0 0 0 0 0 5, okay? What is the diagonal? The diagonal is simply this. But outside diagonal there is a non-zero number. Where is that? This one is not zero, right? So outside the diagonal there is a non-zero entry, therefore this matrix cannot be diagonal, okay? So basically you check the diagonal, you mark the diagonal, and outside the diagonal if there are all zeros, then it is diagonal matrix. Otherwise, if there is at least one non-zero, that cannot be a diagonal matrix. That is all about diagonal matrix. And order can be anything. It's 3 cross 3, not necessarily 3 cross 3. You can also write a big 4 cross 4 matrix also. Just write some numbers in the diagonal, okay? And all other you put zeros, all other zeros, okay? So only non-zero can be this. But one of them can also be zero, like here, okay? Diagonal entry can be zero, but outside the diagonal all must be zero for a diagonal matrix, okay? So an identity matrix of order 4. Identity matrix means all diagonal entries, all diagonal are 1, okay? Outside diagonal, what happens outside diagonal? Outside diagonal all are zero. So basically what? This is a restricted diagonal matrix, you can say. So here I will write a 4 cross 4 identity matrix, which means what? All diagonals are 1, so you can write, since order is 4, you can write 4 1s here, okay? And outside diagonal all are 0, which means what? You have to just put all zeros here, all the positions, okay? All the positions. Similarly, this is 0 here, this is 0 0, and this is 0 0 0. So this order you can check, it is order 4, means only one digit is given, which means 4 cross 4. and all diagonals are 1. This case all diagonals are 1. Yes, all diagonals are 1. Outside diagonal all are zeros. Yes, outside this all are 0. So basically this is an identity matrix of order 4. Similarly, identity matrix of order 3, what it will be? 1 0 0 0 1 0 and 0 0 1. Diagonal all are 1. Yes. Order is 3. Yes, 3 cross 3. And outside diagonal all are zeros. Yes, outside diagonal all are zeros. So it is an identity matrix of order 3. So basically this is 3 and this is 4. Okay, and upper triangular matrix. Upper triangular matrix means, so there is this diagonal, we know, right? Below the diagonal, so I know there is a diagonal here. Okay, below the diagonal all entries must be 0. Okay, so one example can be like this: 5 4 1 3 0 2 1 6 0 0 5 4 and 0 0 0 3. So if I mark the diagonal, so this is the if I mark the diagonal, this is the diagonal. Okay, and upper triangular means upper triangular means below, lower side must be all 0. Okay, below the diagonal all are 0. So basically I'll write it here. Below diagonal all entries are zeros. All entries are 0. So diagonal, below the diagonal you'll see all are 0. Above it can be anything. So that is actually upper triangular. If it is lower triangular, then the elements after above the diagonal must be 0. So we are considering lower triangular now. Okay. So what is that? Again, all entries, since this is lower triangular, all entries above the diagonal, now above the diagonal are zeros. Okay, so again give an example. So diagonal you can write anything, 2 3 1 then 4. Above the diagonal all must be 0, which means what? All these elements must be zeros. And below it can be anything. Let's say 1 3 4 1 0 and 4 2 minus 1 4. Okay, so this is a 4 cross 4 matrix, okay, which we have given. But this is lower triangular, yes, because above the diagonal, again this is the diagonal, this is the diagonal. Above the diagonal all are 0. Yes, all are 0. That means it is a lower triangular matrix. Okay, and symmetric matrix means what? Around the diagonal you will see a symmetry. For example, diagonal can be anything, but the number here must be equal to the number here. Okay, symmetric matrix. So basically you can say Aij must be equal to Aji. So ijth entry must be equal to jith entry. Similarly, if you see something here, you will also see something here symmetrically. That's why the name symmetric matrix. Okay, let me give a particular example. Okay, so diagonal actually in this case can be anything, 2 1 2 3 1 4. Okay, I have chosen the diagonal. Now if you write 1 here, you have to also write 1 here, because we want symmetry. Okay, suppose this candidate is 5. Okay, and this candidate is, let's say, 6 for example, then 5 completely here it should be 5, and this is 6 here, symmetrically this should be 6 here. Okay, suppose 1 3 in this row it is 0, suppose, then this also symmetrically here must be 0. So and so on. Basically, suppose this is -2. Okay, then this must be -2 because of symmetry. And suppose this is 7, and this candidate then must be 7. So you see one symmetry here around the diagonal. Again, this is the diagonal. Around diagonal you see symmetry. So 1 1 5 5 0 0 6 6 minus 2 7 7. Okay, so basically symmetric matrix means what? This is symmetric about the diagonal. This is what a symmetric matrix is. The skew symmetric matrix means what? This is symmetric but with a negative sign. Okay, symmetry with a negative sign, okay. So what is that? Well, so in this case diagonals must be 0. Okay, one important note in skew symmetric, diagonals are zeros only. Okay, this is an important note because in this case skew symmetry aij equal to minus a ji. So basically if you take any element, okay, the opposite element will be minus of that. So basically this implies the diagonal. So basically if I equal to j, then 2ai I must be 0. This you may not follow. And then aii must be 0. And aii's are the actual diagonal matrix. So well, diagonal matrix means, skew symmetric matrix means diagonals are all 0. Okay, because of this. And then if you write 1 here, it should be minus of that, minus 1. In the symmetric case, it was exactly the same element, but in skew symmetric case, it is the minus of that element. Okay. Now suppose you write 3 here, then here it should be minus 3. Now if you write minus 2 here, then it will be negative of that here, minus of minus 2 will be plus 2 here. Okay, it's not necessary that there should be plus and here it should be minus, nothing like that. So suppose this is minus 5, then what shall I write here? This should be 5. Suppose it is 0, then what should I write here in the symmetric position? Okay, minus of 0, which is again 0, right? And let's say this is 4, then I should write minus 4 here. And this is an example of a skew symmetric matrix. So basically again it is symmetric about the diagonal but with a negative sign. Okay, with opposite sign, simply you can say, right? So 1 opposite sign is minus 1, 3 it is 3 but with the opposite sign, which is negative. This is minus 2. Here symmetrically here it should be the number 2 but with opposite sign, which means plus. So this is plus 2, and this is 4, it should be opposite sign minus, but 0 opposite sign minus 0, which is also 0. So basically 0 means on the opposite you should see 0. Okay, this is skew symmetric matrix, and that's all about this problem.